Okay, everybody, welcome to the final edition of Sony NAB Live. I am Marty Patton. I am here with Ugo Gaglione. He is Chief Technology Officer, Vice President of Technology, Sony Professional Solutions of America. And before we get started with Ugo, what I want to remind everybody in the audience and also watching online is if you're watching online, you can participate by tweeting hashtag Sony NAB, ask your questions, make comments. You also have a chance to win a Sony Action Cam for the best question. Also in the audience, after Ugo's completed his presentation, we'll certainly take questions from the audience, so raise your hand. We can bring a mic out to you. So I'm going to hand it over to Ugo. Ugo.
Okay. All right, good afternoon, everyone. Welcome to this presentation. This presentation is about our desire of moving away from coaxial cable. As you know, we've been using coaxial cabling since the introduction of SDI and high-definition SDI for many years. But as we transition to more sophisticated applications, specifically 4K, it's very difficult to continue using coaxial cables to implement efficient infrastructure of broadcasting plants. And our desire is to start using as much as possible commodity IT switches. Therefore, our dream is to be able to take the IP packets, or Internet protocol packetization of the information directly from our source devices, our cameras, our switches, servers, and use a standard IT commodity environment for connections. Next slide. Then we have some specific requirements and in order to carry out this efficiently. As we move to IP, we cannot remove any of the user experience that we have gained through the years. If I move into IP and have constraints, limitations in switching, then the technology will not be adopted, will not be accepted by end users. Therefore, we need to be able to send real-time video transfer over IP with the same speed and latency specifications that we enjoy today with coaxial cables. Also, the quality has to be full broadcast quality, whether it's high definition, standard definition, or 4K. And we achieve this IP gen locking, because remember, we gen lock devices in production using a technology established by IEEE 1588. This technology is called Precision Time Protocol, and I'll explain that in a few minutes. This allows us to have seamless switching of different devices over an IP fabric. And it has to be agnostic. It has to work with the high definition, ultra high definition, 4K, baseband video, as well as compressed bit streams. Another desire, another feature that people have been asking us to do is we would like to have a single network in which non-video traffic and audio-video traffic coexist in the same environment, as opposed to use multiple layers of different transports. Therefore, coexistence of audio, video, and time-sensitive material, along with control, tally, PowerPoint, email, anything that we take today for granted in conventional IT networks. Next slide, please. Also, a very important issue for us, for Sony, is to be able to reduce the cost of implementing OB trucks, outside broadcasting trucks. As we move to 4K, the cost of wiring is very, very high, because as you'll see in a minute, we need 4 coaxial cables to support a single 4K signal, which will make the weight and cost of trucks very, very expensive. Then the only way to avoid this is to move to an IP infrastructure. Scalability is very important. As you know, in the world of IT, you can begin with very small switches and very easily expand with time. And we need a network management layer to be able to monitor and control the switches that exist in the plant to provide a quality of service equivalent or even better than what we have today in coaxial cables. Next slide. All right, next slide. Yeah. Today, about 2 years ago, we introduced our first step in our quest for IP transmission. This is the NXL 55. It's a device that allows us to multiplex 4 high-definition signals over single Cat6 or Cat5 cable at 1 gigabit per second. Very high quality, and we're using it during the show. We have in the IP stand, a portion of the booth, you will be able to see transmission from Tulsa and Los Angeles directly over IP using this device. But instead of only point-to-point communication, we would like to do multi-point to multi-point communication for a sports application, for broadcast centers. Next slide. Okay, very briefly, because this can be a topic that will take a long time to explain. The IEEE 1588 is a precision time protocol defined by IEEE that allows us to precisely send information of time. Then if you think about, instead of using the traditional synchronization signals that we find in broadcasting, in television, what we're going to do is extract the audio and the video information, and they're going to become packets. But the actual timing of that signal is carried over time messages. Then the king, the absolute most fundamental information that we need to protect during the transmission is the information of time. Then when the packages arrive at the other end, we can reconstruct the waveform and resynchronize the signal using the time information. Therefore, there is the notion of a master clock and slave clocks. And the information that keeps everything synchronized are PTP messages, precision time protocol messages. Next slide. Some of the applications that we are considering, one is very important, is to send information from regional broadcast stations back to the main central broadcast station, or from stadiums at long distances. Then using a straightforward dark fiber, we can send very efficiently IP packages, IP streams of information, all gen-lock. Next slide. Something that probably you have seen or experienced yourself, many cases, a broadcast center decides to connect their entire infrastructure using HDSI. And then when you try to interconnect one center to another center, you have to use tie lines using optical fiber. And then there is this conversion between HDSI and electronic to optical conversion. We can avoid all that by just having a single gigantic 10 gigabit infrastructure that the only thing we do is just sending IP packages. Next slide. As I said in the beginning, one very important objective for us is to facilitate the construction of OB trucks in order to promote the use of 4K and even high definition for multiple venues, for colleges and for stadiums. And we require very low latency transmission and bidirectional communication between the trucks and the broadcast centers, and try to reduce the weight of the truck. Next slide. This is an example of something that we live ourselves. Last year, we built a truck that we use in the so-called Confederation Cup. And right now, this truck is on its way to Brazil to do the World Cup. And the truck is completely using coaxial cable. And every single 4K signal requires 3 gigabit HDSI cables. Then you can imagine the amount of cable that we have in the truck. It's very expensive and weighs a lot of weight. Then we can replace every 4 wires with a single fiber connection. That will reduce dramatically the weight of the truck. Next slide. Then this is our dream. Our direction is to, in the near future, begin implementing IP packaging transmission directly from our studio cameras, monitors, servers, switchers, the Anycast, and in the not very distant future, you're going to see RJ45 connectors, side-by-side to BNC connectors. And these IP packages will be streams of packets. There's the need to have a network management software to provide the quality of service of the entire infrastructure. For those devices that cannot be retrofitted right away or easily, We will have small boxes that will convert IP to HDSDI or HDSDI to IP. These are going to be portable conversion boxes. Next slide. All right, this is what I was saying just a few minutes ago. The most difficult challenge right now as we embark into the transition to 4K is the cost of cabling. Next slide. If you think about a 4K, remember there is no interlace, 4K 60p is equivalent to 4 channels of 1080 60p. 1080 60p is 3 gigabit per second. Therefore, a 4K signal at 60p is 12 gigabits per second. We need 4 coaxial cables to transmit that signal. Then, next slide. Very quickly, you create an enormous amount of cables in any infrastructure. Next slide. Then our goal is to replace these wires either with Cat6, Cat7 cable using RJ45 connectors, or it can also be gigabit and 10 gigabit fiber connection using SFP connections. Next slide. This is a block diagram of a special LSI that we have fabricated. This device that uses and implements the PTP protocol can handle multiple HDs and also multiple 4Ks. Then it can be used with compressed signals or with baseband signals. Now, notice that this device has 2 outputs. And this is very important, because one thing that we all know is that IT switches can be very fragile. They can lose packets. Then the chip or the card can detect if packets are being lost in one of the fabrics, in one of the network output, and can switch very rapidly. It's a failover approach. Therefore, you will never see on air that there is a packet misplaced. But we require 2 outputs out of the switch. Okay? Then you go into the IP network, the packets are reconstructed, there is a decompression engine, and then you reconstitute the audio-video signals. Next slide. All right, this is the small module that we are currently implementing, and we have a chip that eventually we will begin installing in our devices, in our camera. Next slide. Very briefly, we can support up to 4 channels of HD on a single gigabit, or we can support 2 channels of 1080 60p, 4 to 2 10 bits over gigabit, or we can support 1 channel of 60p, 4K, 4 to 2 10 bits, or we have very strong confidence that we will be able to support 2 channels of 4K RAW over 10 gigabit. These are the initial objectives that we have. Next slide. Then along with this technology of precision time protocol, it's very important to maintain the quality of service. Therefore, there is a network management layer that basically creates specific lanes of transmission in the network to guarantee priorities of the audio-video information. Next slide. Then what we're doing is bandwidth reservation or resource allocation. Then the most important priority are the time messages. This is fundamental. If we lose the time information, nothing gets on the other side. Therefore, this receives the highest priority, the control, and then the next level of priorities will be the audio-video information. And the rest of the packages will be information that doesn't require precise time transmission. Therefore, what we call it is a best effort. The information gets there when it gets there. Okay? Next slide. Next one. Then we are showing here at the show, this is a mountable frame, on a rack mountable frame with this frame has capability for 18 slots, and this card can be used for multiple HDs or multiple 4Ks packetized over IP. Next slide. And the software management layer resides on a PC appliance that Sony makes. And it will have a dual functionality. One will be the administration layer to control the behavior of all of the switches in the network. And the other one is going to be able to serve as a router. You're actually going to punch the signal from input and output ports. Next slide. Well, that concludes my brief presentation of our technology of IP. Thank you very much.
All right, a lot of information there. We have several questions coming in online, but I want to give everyone here a chance. If anybody here in the audience has a question that you want to ask Hugo before we go to the questions coming in online? No? Okay, why don't we take the first question that came in?
Okay, so the first question is from Kristen over Twitter. She's asking, how does it ensure precise time synchronization?
Okay. Well, let me see if I can make it simple here. Maybe you have heard of a term called Network Time Protocol, NTP. This is what was used, or it was created back in the 70s to synchronize PCs. When you open your PC and you see your clock, you will notice that all of your PCs have more or less the same time information. The precision of that NTP protocol is in the milliseconds. It's not that bad. But in the 80s and beginning in the 90s, we started confronting power plants, atomic plants, and the industry required to have more precise control of the mechanisms of the industrial plant. Then the IEEE created back in 2004, 2005, this standard called IEEE 1588, and the final revision is 2008. And this time information is related to something called epoch, or beginning of time. Then the beginning of time is midnight of 1969, the transition between 1969 and 1970. That was arbitrarily defined as the beginning of time. Then if you were to imagine, if you were to synchronize a video waveform to that point in time, and you were to advance into the future, 30 years, 40 years, because of the periodicity of the signal waveform, you could reconstruct that video 40 years into the future, because it's perfectly aligned to that moment in time. Something like that happens with PTP. PTP can be locked to your local clock in your television plant, or to a GPS clock. Or you can even lock it to the beginning of the epoch. Then it's measuring clocks, and that time information is related to that moment in time. Then as the master and the slave begin communicating, then they tag the moment of sending the messages. For example, I send you this message, and I have a tag, I have a metadata. Then the receiver says, I got your message. And then you send a reply back to the sender. And then you begin having all these little times of sending and receiving and retransmitting. And doing that, you can calculate the duration of transmission. And that will allow us to reconstruct the waveform.
Want to go to the next question online?
All right, the next question online is from Tay on Twitter. She's asking, are there any limitations to the IP switch over the previous SDI router? And what about improvements?
Okay, it's all about cost of implementations. We can easily create 1024 by 1024 routers. We can begin with a very small router. And as we have more money, we can expand the system. It's probably, there are some initial calculations. We estimate that probably an IP-based router could be 2 times, 3 times less expensive than an equivalent HDSDI router. Imagine if you have a 4K router. Right now, we don't have that. We don't have ways to sending over a single cable a 4K. Therefore, that's not even into the equation. We cannot even estimate how much that will cost. But there are no limitations in how much you can scale the system. It's how much are you willing to pay.
Great.
Right. Why don't we go to the next one online? Now we have a couple more.
All right. Our next question is coming from Jen, also over Twitter. She's asking us, how long would it take to transfer over IP?
Okay. We have an example here in the booth. The transmission latency is made up of a number of factors. One is the distance. If you are in New York and you're sending a signal to Vegas, there is a finite amount of time of transmission. Nothing you can do about it. But also is the latency of the codec, the compressor and decompressor that we use to compress the signal and put them into packets. If you have a conventional codec, it could take multiple frames in achieving the compression. Therefore, there's going to be a latency. Then you may say, imagine a reporter in New York and saying, good morning. It could take a few frames, even 10, 15 frames for that signal to come into Vegas. And then the person in Vegas reporting, hello. Then there's that latency. Sony designed a compression codec that is extremely fast. It's under a field of latency. So in order to minimize the transmission time of the information over IP.
Excellent. If anybody doesn't have a question out here, we'll go to another question that came in online.
All right. So another question coming through on Twitter is from Cheryl. She's asking, is there a maximum distance that the information can be sent or received or transmitted?
No, there's no limitation. In the same way that you could send an email to another person in another part of the world, if you have the connectivity, if you have the routers in place, the IP addresses in place, that video, in theory, can go anywhere. There's no degradation in transmission. You're just sending packets, streams of packets.
Okay.
And we do have one more question.
We have one more.
One more on Twitter coming from Cheryl. She's asking, are specific cameras required to use the NXL IP55, only Sony cameras?
No, the IP55 accepts standard high-definition signals over conventional HD SDI. It can be 720p, it can be 1080-60i, at the number of frame rate. It's just conventional HDs.
Anybody here in the audience have a question for Hugo? Oh, quiet group. Before we wrap this up then, anything that we didn't cover that you want to...
Okay, yes, there's one topic that you may or may not appreciate, but it's very important. There are competing technologies out there. You find other vendors, and there are different standards. You may remember that when Sony created SDI back in the 80s, or HD SDI, at the time they were competing proposals. We ended up creating chips that work, and we gave it to other manufacturers, and slowly we created an infrastructure which was based on de facto things that work. And eventually the standards comply with a de facto solution. Right now we have a standard that have limitations. Some are point-to-point only, some cannot be switched, only basically a streaming from one beginning to the end. Others cannot go through switches of various kinds. There are layer 2 switches, which are used inside the broadcast plant. And there are layer 3 switches that will go between cities or between plants. Then if we are going to adopt a signal that is IP, it has to go through layer 2 and layer 3 switches. Otherwise, the signal will never leave the building. Then right now, the only proposal in the market that is capable of doing that is the Sony proposal. We can go through layer 2 and layer 3 switches perfectly. Other solutions are not doing this.
Well, I want to certainly, unless we have one last question from the audience, I want to thank Hugo for joining us. Excellent topic, and also this also concludes our series of NAB Live presentations from NAB 2014. The winner of the Action Cam, certainly watch the feed, Sony NAB hashtag. We will be announcing the winner shortly. But I want to thank Hugo and everyone here for joining us. This has been terrific. So until next year, this is Martin Patton signing off for Sony NAB.
Thank you very much.